we need to compute the volume of the solid obtained by revolving the region bounded by the two curves about the line x equal to 10. X void. The first curve is 3 times square root of x. So x must be at least 0. So if x is non-negative, so that this square root is well defined. Y equal 3 times square root of x. We know that the minimum is at the point 0, 0 at the origin, because this one is always greater than equal to 0 for all values of x at least 0. Put x equal to 4 and x equal to 1. X equal to 1, we have y 3 times square root of 1 equal to 3. 1, 2, 3. So another point here, we also have x equal to 4. So y is 3 times square root of 4. So 3 times 2, which is 6. 2, 3, 4. 6 here. So we have this point. The other one is x, y equal to x. So something like that for y equal to 3 times square root of x, y equal to x, 1, 1, 2, 2. So this line. We want to find the intersection point of the two graphs. And we have say this has a coordinates x1, y1. We know for sure the origin is one intersection point. The other one say coordinates 0, 0, x1, y1. We want to reform this region about the axis x equal to 10. Let's check if x equal to 10 is here or there. So we know for sure that one intersection point is 0, 0. The other one can be determined from the equation of the two curves, y equal to 3 times square root of x and y equal to x. So we have 3 times square root of x equal to x, gives us 9 times x equal to x squared, we square both sides. Then we have x squared minus 9 times x, so x minus 9 equals 0. So x equal to 0 and x equal to 9. So x1 is 9. And therefore the other one, because the point is x1, y1 is on the line y equal to x, so the y coordinate is also 9. X1, y1 is 9, comma 9. So the line x equal to 10 is here. X equal to 10, let's put it here. So our region look like that. Now, by revolving this region about the light x equal to 10, each point on the blue curve give us this circle. So and here each point on the green curve give it this. The green line give it something like this. The blue line give it something like this. So every point on the blue one give it this bigger circle. Every point on the green one give us smaller circle. At this point 0, 0, the two circles are the same. So what we have would look like this, and there's a hollow part. The blue outside, the green inside. So the region would be like this figure. This part is empty inside here. Okay. By the methods of slicing, we slice the solid by plane perpendicular to the axis of revolution. We will compute the volume by the washer method. So everything slide could look like this. It is a very thin part. The cross section is a washer, where the inner circle is one given by the green curve y equal to x. The outer circle is one given by the blue curve y equal to 3 times x. And we slice it so that 8 pieces is so thin. So we slice it perpendicular to the axis of revolution. It gives us a partition of this segment. So from y equals 0 to y equal to 9, which is a coordinate of this point 9, 9. The corresponding point here is 9. So we have a partition of the segment 0, 9. So 18 pieces has the width delta y. When delta y tends to 0, we have dy. And the area of the cross section is the area of the blue circle minus the area of the green circle. So the outer radius is a distance from the outer circle to the axis of revolution, to the line x equal to 10. So this is outer radius. And the inner radius is, if we consider the same point, the length of this segment gives us the inner radius. So the inner radius is a distance from the inner circle. So from point on the line y equal to x to the axis of revolution. So the length of this segment gives us the inner radius. So now let's compute the outer radius and inner radius. For every point here, of coordinates x, y, here's x, here's y. The outer radius is this distance from the point on the blue curve to the axis of revolution. The distance from the point xy to the axis of revolution, x equal to 10, gives us an outer radius. The outer radius is a distance from this point to this point. This point corresponds to x equal to 10. This point corresponds to x. So we have our outer radius is 10 minus x. Since we are talking about the integral in terms of y, so we are doing dy here, we want to write down this outer radius as a function in terms of y. So in our case, 10 minus x equal to 10 minus, we're going to write x in terms of y. So here we have 3 square root of x equal to y. 3 square root of x equal to y. This means 9 times x equal to y square. We square both sides. So this means x equal to y square divided by 9. X equal to y square divided by 9. So this gives us the outer radius. We want to write down everything in terms of y. That's why we do this. And for the inner radius, r inner is a distance from this point. The point lies on the green curve, y equal to x, to the axis of revolution. So this point corresponds to here. So say, if we have a values to the point x, y, where x is here, then the length from here to here, so is 10 minus x. So r inner is 10 minus x. X equal to y. We want to write down as a function in terms of y. So this is 10 minus y. So we have r outer and r inner. We can compute the area of the cross section. The area of the cross section is the area of the washer. So pi r outer square minus r inner square. Pi times r outer square r outer square minus r inner square. R inner is 10 minus y square. So this is the area of the cross section. And now we are ready to set up the integral. The integral is the volume of the solid. We need to compute is the integral from 0 to 9. So 0 and 9 correspond to intersection point 0 to 9 of the area of the cross-section. And dy. By some computation, we get the volume of the solid.